Hello everyone, I am Raghuvanshi Battini and my team members are Vishnu Devineni and Rajesh Pannaganti. And our project title is Face Analysis Using Deep Learning. Coming to introduction, we all of us know human feel facial expressions can be easily classified into 7 basic emotions. Those are happy, sad, surprise, fear, anger, disgust, and neutral. And humans are well trained in reading the emotions of others. In fact, at just 14 months of old, babies can already tell the difference between the happy and sad. But can computers do a better job than this in assessing emotional states? Uh, Coming to objective of our project, emotions are small digital images used to express an idea or emotion in an electronic communication and have become very popular in recent years. Um, the emojis have become an integral part of our digital communication and serve as a normal non-verbal cues for expressing emotions or feelings. Advances in computer vision and deep learning have made it possible to detect human emotions from photos and classify them to map corresponding images or avatars. Uh, as I said, we use it 6 different types of facial emotions. Those are angry, sad, surprise, fear, happy, and neutral. We previously mentioned only 5 emojis in our proposal, but we extended into 7. Uh, Coming to our approach, we used deep learning models. Those are CNN and LSTMs, and we compare our models. Like we compare our accuracy of CNN and LSTMs. The model will be then used to locate an appropriate avatar or emoji used based on the defined emotion. The dataset of our project is taken from the FER 2013, which consists of grayscale facial emojis that are 48 by 48 pixel in size. And by training a deep learning model on this dataset, it will be possible to accurately classify facial expressions and associate them with the appropriate images or avatars. Uh, these are the different libraries we used. Those are pandas to extract the data frame, and we used the NumPy to generally calculate the matrices and other multiplications using math. And those are like we also use the TensorFlow, DataTime, CV2, OS, Seaborn, and MATLAB. We all of us know what about the CNN is. It is used to commonly applied to analyze visual imagery. CNNs are composed of multiple layers of artificial neurons, and when you put an input into the convolution, each layer generates several activation functions that are passed on to the next layer. And moving forward, LSTMs are artificial neural networks used in the field of artificial intelligence and deep learning. Generally, LSTMs use additional gates to control what information in the hidden cell is exported as output and to the next input states. In addition to the input state in traditional RNNs, the architecture for an LSTM block typically has memory cell, input gate, output gate, and forget gate. Uh, Remaining part will be explained by the Vishnu Devnani. Thank you.
Hello, this is Srinag Vishnu Devneni. I'm gonna I'm gonna discuss about CNN model, and my friend Rajesh gonna discuss about LSTM. We're gonna take these two models and train with the same data set, and we're gonna check which one can perform better output. So first going to CNN, we have built a convolutional neural network and a Longchamp and LSTM model will be developed for recognizing facial emotions. The FER 2013 dataset will be used to train the model. All documentation and code for the project will be available in our GitHub repository that will be uploaded in the final project. So the evaluation methodology for the project involves like data preparation, developing a CNN model and also LSTM model. We'll divide the data sets into training, validation set, and testing data. And we'll classify all the input data into 7 classes as my friend named. And also coming to the code, this is the CNN emotional detector code, and these are all the libraries that we have um, And this is the Google Drive. We have mounted the Google Drive and we have imported all the data sets here. And the dataset contains 48 rows and 48 columns with 7 classes. Those are surprise, angry, neutral, happy, fear, sad, and disgust. This is the input data structure, and you can see the bar graph of it here down here. And we have got all the all the data sets structure here in the bar graph. And now we have we have split data into training and testing with 28,719 images for the training dataset and 7,178 for testing dataset. And we have named the classes angry as 0, disgust as 1, fear as 2, happy as 3, neutral as 4, sad as 5, and surprise as 6. We have developed two CNN models. Uh, as the first one you can see here. The model takes the input layer with a specified input size, and the convolutional layer detects specified using filters with 32, 64, 128, and 256 for the model 1. The normalization, the inputs of each layer, making the network more stable and accelerating training. For maximum pooling, we reduce the spatial dimensions of the representation and also reduce the computation in the network. To drop out randomly, we sets a fraction of input units to 0 to each equate during training to prevent overfitting. In the same model 2, but the difference between the model 1 and model 2 of the CNN is up only the architecture with different configurations in terms of layer sizes, kernel sizes, and regularization techniques. So after this, we have got the model 2 accuracy is better than the model 1. So we would like to take the model 2 as our final output for CNN model. And so later we have checked the accuracy for both, and we have got the loss accuracy and accuracy for plot, loss and accuracy plot for model 1 and for model 2 here. And down we got the evaluation for model 2. So this is the confusion matrix for model 1, and this is the confusion matrix for model 2. All the results going to be explained by my teammate Rajesh, and he's going to explain about LSTM2. Thank you.
Coming to LSTM, both CNN and LSTM can be used for emotion detection tasks. LSTMs are predominantly used to learn, process, and classify sequential data. Because these networks can learn long-term dependencies between time steps of data, LSTM and CNN layered structure, when used for image classification, has an edge over conventional CNN classifier because of their long-term dependencies over memory ability. Here you can see we are creating a sequential bidirectional model. So here we are using LSTM, and you could see we are adding layer by layer. So LSTM, dropout layers, then we add a dense layer, then another dropout, batch normalization, then we store our model, and then we compile our model, and this is the structure of our CNN. You could see all the layers here, and then we fit our model on our training data. And you can see we are running a box. Here we can see the loss and accuracy plots of the model we trained. So coming to the last one, we could see as the epochs can train the model, the loss of both test and train keeps falling. While coming to the accuracy, as you going through the more cycles, the accuracy of the model increases significantly. Coming to the results, here we could see we have passed one image and the model predicted it to be an angry image. We predicted this one to be sad. And when we passed this cricket player image to the model, it gave us him to be a happy image as surprise. Thank you, Professor.